Alrighty. Okay, so triangles. I want to talk about midpoints, medians, and I guess area. Although I guess we'll talk about areas a little bit later on as well in future videos. So I guess first things first, midpoints. Okay, so what is a midpoint? So if you take a line segment, so that can be any line segment. Let me kind of copy this down. So imagine I took this, all right, and I kind of broke this triangle up like this right here. All right, so I'm just breaking it up. I'm like removing, okay, so I'm just separating it out. So midpoint is simply the point in the middle of a line segment. So if you take this line segment from here to here, okay, so the midpoint, now I might be off a little bit here in terms of where the midpoint is. We can measure it out. Okay, so that would be the midpoint. And we can do that, all right, with all the line segments. So let's say this would have been a midpoint right here, and let's say midpoint right there. So if you have a triangle, you can put the midpoints up on those triangles. So that's something that we may want to know. There's some neat things that happen once you do allocate and see what the midpoint is. Now, what is a median? Well, a median is, so if I say this was the midpoint right there, all right, so right there we had a midpoint at the bottom. And if you take the opposite vertex, so let's say right here, and you connect the vertex to the midpoint of the opposite side, then, okay, so this segment that you just drew is known as the median. So it kind of bisects our triangle in a way. And you can do that, of course, with any of the vertices. So for example, I could remove this right there, and I can say, let me take this and then the midpoint right there. And if that was the midpoint, we could have drew a median like that. And you can do that from any vertex of a triangle. All right, so now we know what a midpoint is, and we know what a median is, and how to allocate those. Now the area of a triangle, so this is neat, right? And we kind of should know what the area of a triangle is. And most people may remember that it is the base multiplied by the height of the triangle divided by 2. Now, we typically just say base times height, divided by 2 in that way, or in some fashion like this. Where did this come from? So let me give you just a little glimpse into where this has come from. So imagine that we have a rectangle. All right, so I'm going to draw a rectangle here, or a square, whatever it may be. But the point being is that we have, our angles are 90 degrees. All right, so all our angles here are 90 degrees. All right, so now when the angles are 90 degrees like they are in rectangles and squares, for example, then it's easy to find the area. So the area, the ultimate area, is basically, so if this was your base right here, all the way, and this was your height, then everybody can see that it is base multiplies by height, and we have the area of a rectangle or a square. Now, let me remove this, and if I cut this in half, so making it triangle, then you can see that indeed it makes sense that we have, okay, so this triangle here, or the other triangle here, so the area would have been half of that rectangle because we cut it in half. All right, so we bisected it. Now, not every quadrilateral is a rectangle, or it is not a square. So we don't always have 90-degree angles where we can easily see it. So what would have happened, okay, if instead we had, so let's say I had, say, something like this. All right, let me redraw it here. Okay, so I'm going to draw it, let's say, something like that. All right. And now, if we're going to do this, let's take a look and see, okay, so how we can actually maneuver this. Now, because all of these different triangles, they can kind of be shifted apart. So what I want to show you is I'm just going to rotate this. All right, so let me rotate it flat like that so that it looks a little better for us. So clearly this is not 90-degree angled triangle. So if it is not, then what can I do? So I'm going to do something similar. I'm going to say, so here is my base. All right, so this entire thing is my base. Now, I'm going to divide this up. So I'm going to divide this triangle up. And I'm going to say, all right, so here is my height. Okay. Now, this height, I can now break this into 90 degrees. So the area of this triangle is basically the area of this triangle plus the area of this triangle. And here, so right there, this is our height, right? So we're trying to see, okay, if we're going to get this as our area of a triangle. So let me work with area number 1. So area number 1, so what I'm going to do here is, if that's my entire base, so I'm going to, for instance, okay, so let's just say, okay, so that the smaller triangle in here, let me clean this up a little bit so it looks a touch better. Okay, so I'm going to say, all right, so from here to here, I said that this was B. Okay, so that was my base. And now what I'm going to say that from here to here, okay, so this right there, so that, let me call it, you know, let's say this is base, and let's make it A, or something like that. So that means that from here to here, all right, so this, okay, is really, so the entire base minus A, right, because we're just going to subtract that A. So since these are two right-angled triangles, I can say that my area 1 plus area 2 is my overall area. And let me break this down. So notice that area 1 is my base, which is B minus A times my height, plus, okay, my area 2, which is my base, in this case it's A times H. Now both of these, because they're triangles, okay, they're divided by 2. So notice I can now bring the H inside of the bracket, so I can expand this. I'm going to get B times H minus A times H. And this is going to be all over 2, so plus A times H over 2. So really what I have is the following. And the whole thing, because it's just fractions, is over 2. And now the minus AH with the plus AH, okay, cancels. And indeed, my overall area is just base times height over 2. And that's my area of a triangle. So if you wanted to know and see, it should make sense to you that the right angle triangles is base times height times 2. But if it's not a right angle triangle, you can cheat a little bit and divide it into two smaller triangles and then add the area, which you can see is again just base times height, okay, divided by 2. So what have we learned? Well, we have learned what a midpoint is within these triangles. Okay, we've learned what a median is. Okay, and we kind of can see what the area of a triangle is. Now you can do a lot of neat things with these, you know, midpoints, medians, and areas, and so on. So for example, a very common one if you're in school, Okay, so what you will have, let me clean this up a little bit now that I don't need this. Okay, so if you take a triangle, so for instance, let me take some triangle like this. And so you have your vertices right here. Now, if you say, for instance, find the midpoint. So let's say the midpoint on this line, so let's say it was somewhere here. Now the midpoint on this line was somewhere here. And if you connect these two, okay, now you can do quite a lot of different things about these. So some of the questions which I would have for you, now it may seem obvious, but I would want you to kind of prove it to yourself that these two lines are actually parallel, right? So if they're parallel, then those interior angles in there are the same, okay? And that's what we have learned about that already, okay? About triangles and angles. I can put a link up above again if you want to see that, right? So for instance, this angle and this angle would be the same, and then this angle and this angle would have been the same, and of course they're sharing this one. Now there's something else that we may want to know, and that is with regards to, so for instance, if this is your base right here, okay, so this is actually base divided by 2, so it's half the length. And you can think about that as well. Why is that the case? And for my daughter, who's going to be watching this at some point, I would want you to let me know why it's actually half and think through it. And anyone who likes, they can put a comment below why that would be the case and what your thought process is behind it. All right. And another question that I love to ask is, because I said that these two lines were parallel, so these two lines were parallel, I would say prove it. Okay, so prove that they're parallel. You can think about that, and you can put that in the comments as well. All right, if you wanted to. Okay, so that's pretty much it. All I wanted to say about what a midpoint is, what a median is, you know, the area of a triangle, so you can kind of see where it's coming from. And these ones, I'll leave some of these questions to you. Hopefully we'll see some comments eventually come up, because I know that the videos take a bit of time to try to trigger through the internet world. Okay, so thanks for watching. We'll see you in a future video. Okay, bye. Take care.